Hello, grade 11. Welcome to our general mathematics class. And welcome back to school. So you are now a senior high school student. This is teacher Riza, or you can call me Mom Bryce, your general mathematics teacher. So our first lesson for general mathematics for this week or the first week of the first semester is function. And this is our lesson 1.1. With learning competency, represent a real life situation using functions including piecewise functions. And our objectives for this lesson is recall the concept of relations and function. Then second, we have define and explain functional relationships as a mathematical model of situations. And third, represent real life situation using functions including piecewise function. Now let us review how to solve an equation during your mathematics in junior high school. To solve for an equation y is equal to 2x plus 1 is we're going to assign values for x to get a value of y. That is, if x is equal to 2, substitute the value of x, which is 2, so that's 2 times 2 plus 1 is equal to 5. And if x is equal to positive 1, so substitute x, which is 1, so that's 2 times 1 plus 1 is equal to 3. And if x is equal to 0, so that is y is equal to times 0 plus 1 is equal to 1. And if x is equal to negative 1, then y is equal to 2 times negative 1 plus 1 is equal to negative 1. And if x is equal to negative 2, so substitute also the value of x, so that's 2 times negative 2 plus 1 is equal to negative 3. Now, let's group the values for x. So that's x equal to 2, 1, 0, and negative 2. And for the value of y, we have 5, 3, 1, negative 1, and negative 3. Wherein the set of values of x is called the domain, and the set of values for y is the range. So from here, if x is equal to 2, then y is equal to 5. Then, if x is 1, this corresponds to the value of y, which is equal to 3. And x is equal to 0 is related to the value of y, which is equal to 1. That if x is negative 1, this corresponds to the value of y, which is also negative 1. And x is equal to negative 2 is related to the value of y, which is negative 3. The domain is also called the independent variable. And the values for y or range is also called the dependent variable because the value of y depends on the value of x. Since y is the dependent variable and y depends on the value of x, that if x is equal to 2, the value of y will be equal to 5. Therefore, y is the function of x. And this will be y is equal to f of x, or the function of x. So what is a relation? A relation is a rule that relates values from a set of values, which is the domain, to a second set of values, which is the range. So from our example, we have here the domain x and the range, which is the values of y, wherein x is related to the values of y, wherein the rule is the sum of 1 and twice the value of x. And what is a function? Function is a relation where each element in the domain is related to only one value in the range by some rule. That means for every value of x corresponds to exactly one value in y. So there should be a unique value for every x in the y, exactly one value. So we have here the types of relation. The first one is one-to-one correspondence or one-to-one relation. That is, for value of x1, this corresponds to the value of y, which is 4. So this is 1 to 1 correspondence. Then next we have 1 to many. For value of x, which is 1, this corresponds to the value of y, which is 4 and 5. So there are two values for y, so that's already many. So that's 1 for x and many for y. So that's 1 to many correspondence or 1 to many relation. Then we have many to 1 relation. For x, we have 1 and 2. This corresponds to the value of y, which is only 4. So many for x and only 1 for y. So that's many to 1 relation or many to 1 correspondence. Then next we have many to many relation. That is many values for x and also many values for y. Which among the four relations are functions? So remember that the definition of function is a relation where each element in the domain is related to only one value in the range by some rule. So, one-to-one relation is a function because one value for x and only one value for y. And one-to-many is not a function. It is only a relation because the one value for x and more than one value for y. So this is already one to many relation, and this is not a function because there should be exactly or a unique value in y. The next, so this, if a relation is not a function, then it's called a mere relation. The next we have many to one. Okay, so many to 1 is a function because every value for x corresponds exactly one value for y, so therefore this is a function. And next we have many to many. Since there are more than one value for y, so this is already not a function, but it's only a relation, or that is a mere relation. So this means that not all relation is a function, but all function is a relation. So, we're going now to relate function in real life situation. For example, a student and its a learning reference number. Remember that every student has only one learning reference number, or LRN. So this is one-to-one relation and it is a function. Then another is a country and its capital. Every country has only one capital, so therefore this is a one-to-one relation and it is also a function. Then the relation of senators and the President of the Philippines. For 12 senators, only one president, so therefore this is a many one-to relation and it is also a function. Now, how are we going to determine if a relation is a function? We can check if a relation is a function by means of mapping or arrow diagram. So we already use mapping here, wherein we group the values of x and y, and we use arrow diagram to show the relationship of the value of x and y. The next we have set of ordered pairs. So from the equation we solved a while ago, we have the values for x, we have 2 and 5, so we have the set of ordered pairs are 2, 5, 1, 3, 0, 1, negative 1 and negative 1, negative 2 and negative 3. So this is the set of ordered pair. Then next we have table of values. For table of values, we have the set of values for x and the set of values for y. Then we have also graphing. If we're going to graph the table of values or the set of ordered pairs, so we have here the graph of the given function, and the equation is y is equal to 2x plus 1. So therefore, we can determine the relation if it is a function or not through mapping, set of ordered pair, table of values, graphing, and equation. Now, the question is how to determine if a relation is a function. So by means of mapping or arrow diagram, so first we're going to identify what kind of relation. for the domain and the range. Since this relation is 1 to 1, so therefore this is a function. Then next, for mapping an arrow diagram, since the relation is 1 to many, so therefore this is not a function but it's only a relation. Then the next mapping or arrow diagram, we have, since for x we have 2 and 1 for y, so therefore that is many to 1 and it is a function. Then the last example is we have this is many to many relation, then therefore this is not a function. The next, what about from the set of ordered pairs? For example, we have negative 2, 3, 4, 5, 6, and negative 5. So first, we're going to identify the range and domain and its relation, wherein the domains are negative 2, 4, and 6, and the range is 3, 5, and negative 5. Since the relation is 1 to 1, so therefore, this is a function. The next example is we have 1, 6, the set of ordered pairs of 1, 6, 2, 5, 1, 9, 4, 3. So we have here, the domain is 1, 2, 1, and 4, since 1 is repeated here, and for the range we have 6, 5, and 9, 3. So that means the domain 1 has 2 pair for the range, so that is 1 to many relation, and this is not a function. For number 3, we have set of ordered pair of 1, 2, 2, 3, 3, 3, and 4, 5. The domains are 1, 2, 3, 4, and the range is 2, 3, 3, 5. Okay, since the range, the number 3 for the range is repeated, so therefore the relations here is many to 1, and it is a function. What about for the table of values? So same for the table of values, we're going to identify the relation. Since the relation for this is 1 to 1, so therefore it is a function. And the next table, we have here for the value of x1, we have 2 pair for y, that is 3 and 4. So therefore this is 1 to many, and this is not a function. Then for the third table, we have for y, 2 is repeated, so that means for x1 and 2 corresponds to y, which is only 2, so therefore the relation is many to 1, and it is also a function. What about for the graphing? For graphing, we're going to use the vertical line test. That means we're going to draw a vertical line along the graph. That is, if a graph represents a function, if and only if each vertical line intersects the graph at most once. So this means if the vertical line intersects the graph at exactly one point, then therefore it is a function. But if the vertical line intersects the graph at 2 or more points, then therefore the graph is not a function. Okay, for example, so we have here a graph of a slanting line. So if we're going to draw a vertical line here, so the vertical line intersects the slanting line at exactly one point, so therefore that is a function. Then next we have a parabola which is open upward. Drawing a vertical line, this vertical line intersects also the parabola at exactly one point, so therefore this is also a function. Then next we have a parabola which is open to the left. So if we're going to draw a vertical line, the vertical line intersects the parabola at 2 points, so therefore this is not a function. Then next we have the graph of a circle. So drawing a vertical line, the vertical line intersects the graph or the circle at 2 points, so therefore this is not also a function. And we have also the sine graph. Drawing a vertical line intersect the graph at exactly one point, so therefore this is a function. And last is by equation. Okay, so for y is equal to 3x minus 2, this is a linear equation, and linear equation is also a function, or that is a linear function. For the equation y is equal to x squared minus 2x plus 2 is a quadratic equation, and this is also a function, but not all quadratic equation is a function. This is only for x is quadratic. For x squared plus y squared is equal to 1 is an equation of a circle, and this is not also a function. So we have here an example of functions are linear function, inverse function, constant function, identity function, absolute value function. We have also the rational function and the polynomial function. So function is just like a machine, wherein where there is the input and the output. So when you put an object into a machine, you expect a product as output after the process being done by the machine, wherein the input here is the value of x and the output here is the value of y, or that is function of x or f of x. Function as a machine, for example, if your input is any letter from the alphabet, so output can be a vowel or consonant. So if your input is a whole number, so therefore the output is also a number. So function notation. For an equation y is equal to 2x plus 1, where in the equation that we solved a while ago, where y depends on the value of x and y is the function of x, so therefore y is the function of x or f of x. That is, if a relation is a function, then y can be replaced with f of x, which means function of x. So an example of functional notation is f of x is equal to 5x minus 2. Aside from using f of x, we can also use g of x. An example of function is x squared minus 2x plus 1. We can also use h of x. For example, that is 3x minus 5. Or we can also use q of x if that is 2x plus 5. So therefore, from y is equal to 2x plus 1 equation, so this will be now, y can now be replaced by f of x or function of x is equal to 2x plus 1. So we can also represent function in a real life situation. So functions can be often used to model real life situations. Identifying an appropriate functional model will lead to a better understanding of various phenomena. For example, for buying a milk tea, if C, which is the cost, is the function of N, which is the number of milk tea, represent the cost of buying N milk tea if one milk tea costs 120 pesos. Since C is the function of N, so therefore this will be now C of N. And one milk tea costs 120, so multiplying the number of milk tea, so that will be now C of N is equal to 120N. Another example, if distance D is a function of time T, so give a function D that can represent the distance a car travels in T time. If every hour the car travels 60 kilometers. Since distance D is a function of time, so therefore that is D of time. And every hour, which is T, the car travels 60 kilometers, so therefore that will be 60 times the time. So therefore we have now D of T is equal to 60 times T. But some situations can only be described by more than one formula, depending on the value of the independent variable. And this is called the piecewise function. An example, because of pandemic, a trike ride in Kawayan City costs 20 pesos for the first 4 kilometers, and each additional integer kilometer adds 2 pesos to the fare. So use the piecewise function to represent the trike fare in terms of the distance D in kilometers. Since there are two conditions here, the first one is you're going to pay 20 pesos for the first kilometer, so therefore that will be 20, wherein the distance is less than or equal to 4 kilometers. But you're going to pay another 2 pesos for every kilometer, so that will be F. Since F is the amount of trike fare, so that's F of D. So F of D now is equal to 20 plus 2 times the distance, subtract by 4. That is if the distance is greater than 4. So the first condition is 20 if the distance is greater than equal to 4 but less than or equal to 4 but greater than 0. Then the second one is 20 plus 2 pesos times the distance minus 4. That is if the distance is greater than 4. Another example. This is the first plan maybe 3 years ago. A user in charge 300 pesos monthly for a particular mobile plan which includes 100 pesos free, 100 free text messages. Messages in excess of 100 are charged 1 pesos and 50 centavos each. Represent the amount a consumer pays each month as a function of the number of messages sent in month. But today, this is not the offer of a plan now because we have free messages and free calls. Okay, so from this problem, so we have let T of M is the amount paid by consumer per month. And it can be expressed by the piecewise function. The first one is 300 if the text messages is less than or equal to 100. Then the next one is, so the T of M is equal to 300. That is if the messages is less than or equal to 100 but greater than 0. And the next one is 300 plus 1.50 times messages consumed minus 100. That is if the messages is greater than 100. Now, let's try it. A person is earning 750 pesos per day to do a certain job. Express the total salary as a function of the number of n of days that the person works. So that is S of n is equal to 750 times the number of days. Then the next one, Sandra rides through jeepney which charges 8 pesos for the first 4 kilometers and additional 50 centavos for each additional kilometer. Express the jeepney fare as a function of the number of kilometers D that Sandra pays for the ride. Since F is a function of D, so therefore we have now 8 plus 0.50 times D. And we have also a computer shop charges 15 pesos in every hour of computer rental. Represent your computer rental fee using the function R of T, where T is the number of hours you spent on the computer. So we have now R of T is equal to 15 pesos times the number of R, which is T. Okay, for your activity 1.1, that is the assessment, you're going now to solve and explain your answer in a separate sheet of paper. So that means you're going to show your solution. If there's no solution, then you're going to explain your answer. So you're going to choose your answers from the choices. So that's 1 to 4, then 5 to 8, and that is also 9 to 12. And we have also problems 13 to 15. I hope that you already know how to represent function in real life situation. So before we end our lesson, so let me share this. School open for the new welcome session. Everyone student have great hope to learning expectation with more fun and simpler treat. Achieve the goal for nice conclusion. Every student and teachers improve learning with nice vision. And that's all for today's lesson. Thank you for listening and watching. So again, this is Teacher Riza saying stay home and please stay healthy. Have a nice day. Please don't forget to like and subscribe. Bye.